G'day guys. Remember, I was always trying to get these PIs, pulse induction detectors, to be as sensitive as a VLF. Well, I'm getting pretty close to that threshold. If not, I think I may have surpassed it. First of all, the pulse induction detector is going to absolutely punch a hell of a lot deeper than a VLF. You know, any sort of VLF induction balance type machine, PI will beat the pants off it all. So here I have the gold monster. Okay, this is a good gold monster too. This one, this is an absolute doozy. But we'll do a little experiment. I'm holding a microphone as well as I got one pinned to me, and I'm doing that so we can get the audio from various detectors so it's nice and loud. So what I'll do, we'll try. I've got my hands full here. What I'll do, we'll use a 0.05 over the gold monster. Now I'm running it as maximum gain as I can, but keeping it quiet. I don't want the chatter. It'll just make the measurements completely ridiculous, and it won't make any sense. So if we go to 0.05, fades off about there. You also got to remember too that these coils have a transmit and a receive winding, and very sensitive in the middle part, compared to the mono type coils that I'm using on the pulse induction. This should be a hell of a lot more sensitive than what it's showing. Well, it is what it is, but the middle part of the coil is extremely sensitive where the windings overlap. Towards the edge of the coil, nothing, and you move in. So it's very sensitive, just in a line down the middle. So you get that pop pop sound as you go over a target. So that's a 0.05. Let's try, nearly had it round the wrong way, 0.012 of a gram. We'll try it out. I basically got to rub the coil as soon as I lift it off, it doesn't detect it. So what I'll do with the microphone now, I'm going to undo that to spin that around. I'm going to put it near the speaker over here. And that's but the pulse induction detector burbling away. Now I have to undo that and turn this around very slowly. And this is in fine gold, and it does not have, I have not put variable gain on this detector. All I've done is put in a very low noise front end, and I've cleaned up. Got to be careful what I say here. I'll explain it in a particular way so that I don't get the the tub of lava poured over me or something of that nature. But you must remember, these pulse induction detectors are an old design. And being an older, they are an old design. They're fairly, what they are. And the thing is, the basic building blocks of that detector, the actual electronic design, is very, very good. They work really well, but they can be improved by modernizing. And this is the whole thing. Every series of detectors from the day when they first came out has been, that basic design has been modernized with every new model. It hasn't changed much. It's been revamped and a little bit of a different way of doing something, newer components, maybe more sampling channels, but that's just in addition to two sampling channels or one sampling channel. You know what I mean? You put in 10 sampling channels. Um, maybe you think it'll be 10 times better. There's all this way of looking at this electronic stuff, and it's the same with everything. You can look at motor vehicles. You put in a 200 horsepower engine, and you get the same car, and you go put a 400 horsepower engine in that car. It's going to go a lot harder. It's the same with electronics. The redesign is like putting bigger motors in, fatter tires. That's the way I see it. And it's a good way to explain it because it's basically it. You know, oh, the car's very noisy now. Well, let's put a new exhaust system on it with some really good high flow baffles, mufflers to get the power through but get rid of the noise. This sort of thing. This is how electronics progresses. There's no magic. It's still putting out pulses and receiving pulses from the target. That hasn't changed. It hasn't, you know, morphed into something totally different. It's what it is. The coils are all basically the same. Coil of wire, there's nothing magic about it. It's maybe different type of wire, different wire spacing, different shielding materials, but it's all an adaptation of an existing design. And these coils I'm using here, these things, they're highly, highly capacitive, and because they're so small, in pulse induction detectors, coils, if you're running the amount of power which you can get out of a GPX detector, it has to have thick wires. I can make it out of thin wire and put some um, loading on it in resistance across it to make it look like it's a low impedance. All that resistor is going to do is burn up energy, and the thin wire is not going to generate much of an electromagnetic field. So you're really behind the eight ball. So there is a limit. There are ways to do it with using ferromagnetics to get the coil size down. Basically, you're changing the value of air, which is one, into a higher value, but you've got to be very careful how you do it. You're wrong iron powders or ferrites or any way you go, even the structure, you do it wrong, it will not work. It will go pear-shaped. So anyway, we had a look at the poor old gold monster down there. So we'll use 0.05 on this detector. I can get that, what's that, 7, 8, 9, 10. 10 centimeters with a pulse induction detector. Okay, now a little bit of noise coming in now. You can hear that. It's 6 o'clock. This is when everyone turns their electric ovens on in the neighbourhood and starts drawing a lot of current through the power lines, and it just induces a heavy magnetic field, electromagnetic field, radiates out and starts upsetting everything. Beforehand, about 5 o'clock in the evening, it was quiet as a mouse. But now we're going to put up the noise. It's always the case. So anyway, here we've got the 0.012 of a gram. Very small target, and I'll just get in here. So let's have a listen. You can hear it. It's in with the noise. Being in suburbia, that's the bane of being in suburbia. So, I'm trying to do it in the middle of the coil. It's very sensitive near the windings. So if you go over it, a very tiny target like that with a small mono, you'll get a double blip from the target, like 1, 2. So that pulse induction detector there, that's a 5000, and it's in fine gold mode. I've got no variable gain on it. What I've done on this one, it was working really well before, but now it's working even better. And what I've done, it's like people say, remember people keep bringing up the argument that you know it's never done. No, 100% it's not ever done, because there's always innovation. Imagine you know, say with something. Here we go. I'll go right out there on a limb. Say we go right out there with cancer, and said, oh, all we can do is chop it out. No innovation, no chemotherapy, no radiotherapy, and everyone died. Fantastic. But the same with detectors. If you don't innovate, you're not going to improve. Innovation is the flavour of the day, and that's what we're trying to do. So, you know, the 0.05, what was I getting up? Around 10 or something. Yep, easy. Whoops, I put the microphone down. Oh, no, oh, this is how long I've been working on this. The battery's going dead. So I've been on it for over probably about 10 hours, and done a lot of modification to the circuit board. We can run this. Well, I'll tell you what. How about I'll turn the back gain. I'll turn the MindLab gain right down on this detector. I'll turn it down to I don't know, 2. How's that? Hang on. Wrong one. I went the wrong way because I'm upside down. Deep. Okay. Okay, that's the detector with a gain of 2. And battery's going to go flat. I'll just do this quickly. We'll just use a 0.05. So the detector's pretty. I can hear it up to 9. So the back end gain's doing not much at all. It's giving you a centimetre, but if you listen very carefully, you could probably hear it at 10 anyway, even with that down at 2. We'll try it. Yeah, I can hear it. I can even go further. You know what you're listening for? Perfect. I can still hear it. I was up at 12. So the back end gain of these things does introduce noise, and the trick is to keep all the noise out of it at the front end. And also, there's part of this circuit on these detectors, I'll call it Mr. Sparkly, right? I'm not going to go into great detail why I call it Mr. Sparkly, but it's a damn noise injector, and it's been proven. And basically, it's the reason why these detectors historically, with a mono on the detector, has worked better with a mono, with a mono in double D mode than mono mode, even though mono mode should give a 3 decibel increase. But if it's giving an extra 3 decibels of noise, right, all that gain goes out the window, and now you've got more noise to deal with. And if the noise is what we call correlated noise, the baby goes out with the bath water. If it's uncorrelated, it doesn't make that much difference, but I've had a look at a noise spectrum. I had to do an FFT analysis on it, and it's basically very, very correlated because the noise is picked up inside the detector. Anyway, I'm not going to go on about it, but there's some critical changes that I've done on this detector to get that sensitivity. Now, this detector, like I tell you, this detector out in the bush, this 5000, will go like an absolute champ. There it is on the bench down there. Spin around. There it is there. Now, this is a customer's detector, right? But he said he didn't want it back for a little while. So it's basically having a lot of stuff done to it. There, I better turn it off. The battery will go flat. Oh, it is flat. And yeah, that's what happens when you work all day on these things. So that detector there is an absolute, over a standard detector. You've seen it in the previous videos. It absolutely, yeah, you know what a cow's good at doing all over it. It is just unbelievable. Now, I've got a detector down here. Where are you? This just got dropped off. I'm going to pick it up the right way because it's got the name on the other side. Now, this is a 4500, and I've been told to make this 4500 as best as I can. So this is the next project. This one here is going to get the latest in it, but I'm also, you know, I should make a video standard and then modify it on this one. It's probably a better way of doing, because there's always naysayers out there who go, yeah, you know. Yeah, they just wake up on the wrong side of bed, and I don't know what's wrong with them, but they just naysay. It wouldn't matter if well, what's the old saying? You can lead a horse to water, but you can't make them drink. And if they don't drink, they'll probably fall over dead. But it's the same thing applies, doesn't it? You can show all you want. So what I'm going to do, I've got this planned, and the people I've got it planned for, I want to see if they will take my modified 5000 and test it against their standard 5000. And I'm not going to go into too much detail because it may be curly to do, but if I can do it, you will be gobsmacked. Put it that way. Yeah, I can't really go into it because I'll let the cat out of the bag, and I haven't organised it, but I'm pretty sure it's a goer. So we can do that, and we can also do it with 45s as well. Look, I don't care. Look, even an old GP Extreme, God, you get the improvement in performance out of a GP Extreme even is massive, huge. It's monstrous. You don't go around getting 0.05s up at 10 centimeters. It's unheard of. You just don't do it. And being able to detect, little tiny nuggets, or a speck of gold. It's less than a pinhead. Picking it up with using a 0. Whatever it is, 0.0, is it 0.012? I've been doing this for so long. Yeah, 0.012. So it's not a 0.1 of a gram. It's literally a 0.001 of a gram with a 2. So it's damn small. It's ridiculously small. I don't know why. Oh, damn, I forgot to show you that even at these oh, damn. Look, I've probably got enough battery in there to turn it on. We'll just turn it back on. It should be where it was. Oops. As these turn on, the power supply goes completely bonkers trying to stabilise and sets off the old gold monster. But okay, here we go. Oh, I'm going to put the gain back up, by the way. I'm going to put the gain up so you'll see this. How about I put the gain up to 20? Okay, this is extreme mentalness, but I'm going to do it. Okay, so gain. Where are you? That's audio. One, go the other way. Okay, gain on 20. Okay, so to prove it's on 20, 0.05. And some of the noise has gone away by sounds of it too, which is good. Whoops, hang on. I've turned this gold monster off too because it's probably going to upset everybody. And also, shushy. So gold monster's off. We'll get rid of that. Over there you go. Now, I'm going to have to do my buff head in front of the detector thing. Okay, we've got some different hot rocks. This is from the US. It's an ironstone of some sort. It's from Nevada, from memory. I've also got some other ones around, but these are the nastiest ones. And I've also, before the battery goes flat, I've also located my really big Kalgoorlie hot rock, as well as the smaller Kalgoorlie hot rock I already had. So it's just that there's so much stuff in this room that things get lost. So what I'll do, I'll just nick in here. Okay, that's me touching the switches. Ate that for breakfast. So that's your Nevada hot rock. We'll try the small one. I'll just go and flick it a bit because it makes it fair. Because it's on slow tracking. Here we go. Oh, come on. Basically got rid of it. A little bit riding on the noise. Now the big one. Because it's bigger, it has a different profile, different return signature. So I'll just flick this again. Yeah, got rid of that as well. No problem whatsoever on the worst of the worst hot rocks. I mean, I could... How about I do all three together? It's a complete mix there. That's a monstrous big hot rock type thing. I'll just flick it into fixed, then back into tracking again. Fixed. Did it for my thumbnail so it didn't go off. There you go. Doesn't care less. No problem whatsoever. So that's on a gain of 20. The front end of this detector is so quiet, and I actually designed it that way, that it's not going to pick up a lot of noise. Even though I'm running the cancel phase or the cause, like imagine in mono, I'll flick this so it operates in a proper mono mode. You have a listen to the noise in this room. So I'll just flick it into double D, so it's used as one coil. Okay, so that's the detector flat out for gain of 20. It's just totally over the top. So basically, everything on this is cranked up, but like I say, it does not have my variable gain stage. So I can make this detector variable frequency, put in all the good stuff. Yeah, turn it off. No, hang on, I'll just do the 1-2 again. You can hear it in the noise pretty easily. But like, yeah, getting down to that size target is really amazing. You know, that's something that the SDC was meant to do, and get down to tiny gold. Or even the VLFs are meant to get down to tiny gold. But The thing is, if you do things a particular way and don't just stick with the way things have been done and do it differently, you can make a huge improvement. So I dare anyone to get a 0.012 and detect it with their pulse induction detector. I wouldn't care what it was. It won't pick it up. I know for a fact it won't pick it up. So there we go. That's the detector done. But like I say, I have changed very critical componentry, and I've done a lot of add-on. And yeah, it's at the moment it's all covered under. I've re-white painted it, and I've done the industry standard. It's called grind off numbers off chips, and so forth. I think that's been set as a precedent to grind the numbers off everything. So I will continue the tradition or the practice of doing that. So I'm just having a bit of a laugh. Okay, the tradition of grinding numbers off. Yeah, okay. Sorry, we don't know what chip that is, because I don't own an oscilloscope and I can't work it out. Oh God. Okay, but this, the same thing suffices. I pulled stuff off that board and replaced it, both sides, and it's also got the extra modules in there as well, and some other tricks of the trade, which I actually am very purposely being very careful how I change stuff now. And basically I'm trying to make it look like it was machine soldered, thus, and covered up nicely, cleaned up and repainted. And by doing that, that should stop copycats, because I hate doing all this hard work just to have copycats undermine and claim it as their idea. I think I've mentioned it in about 50 videos ago, where a fellow was doing detectors. It caused a big ruckus, blew a few up, sent them to me to get fixed, and then was trying to copy what I'd done. And I got the feedback off the people involved. He was telling them that he taught me everything I knew, right? And he'd been dabbling with detectors for about 5 years, and at that time I'd been dabbling with them for about probably about 42 years. So he taught me everything I knew. He must have taught me in my mother's womb or something. So yeah, these characters are out there. I don't have a lot of time for them, and I know how they operate. So from now on, nah, you're not going to find out what I do. I don't care if you pull that apart and have a look. You probably won't work it out. There's a lot of it there, especially with some of the part replacements. You just won't know. You won't know why. You won't know how. It's a good idea to obscure all this stuff, so it just stops the copycats. It's hours and hours and hours of work goes into this, and you just don't want to give it away. My God, I'm not a benevolent fund for opportunists. No, it doesn't work that way. So I'm actually designing up just so you know, I'm designing up complete new boards at the moment, and I'm going to get them. I'm doing them in a way that I can actually, um, put them in an epoxy type compound that doesn't get eaten away by chemicals. So if you break it open, you'll rip all the parts off the board. You'll never know how it worked. So look, this is stuff for the future. I've got other projects I'm working on. So yeah, but at the moment we'll just keep going with what we're doing, because it works so damn well. It really does. And if anything really, really good comes up in the future, that is, um, a really big difference to what I've already done. We always look after our customers. Just send us the detector and I'll upgrade it. As long as you cover the postage, right? So that was mainly for the newer 5000 mods, because it's a continual, how would you even say it? It's just continually examine and replace. oh, new parts have turned up, Company XYZ has put out a better version of, ABC. Well, I'm putting that XYZ in ABC's position. That's going in there. I may have to change things to make that work. But if it's got something like half the noise figure or something like that, it's going in. It's going to make an improvement. So the whole thing is make improvements, make improvements. Probably if I'm still doing this in 10 years' time, I bet you I can still get these detectors here, and it'll look a lot different, of course, and I bet you it'd probably blow everything out the water because the basic design is nothing wrong with it. There's so much I can change on these detectors, but it'd be like building a new detector. Um, I just look at that now and I just see noise. I know there's components there that add so much noise, and I know there's better stuff out there. God, I want to do it, but the time, you know, this detector's like, it's probably on this one here, I don't know, what, 8, 9, 10, 12, could be about 15 hours have gone in on this just to prove a point. So, yeah, but after that 15 hours is done, it probably gets turned into, just a good day's work and, carefully swapping things over and changing things. So I hope people do understand that. And I'm doing this video now, especially on the weekend, because everyone's out prospecting. I don't want a lot of people to see it straight off. It can just drift around and people can watch it during the week. Because, yeah, it's just one of those things. If I put a video up on Sunday night, my God, it gets hit really hard and fast. And, yeah, in the middle of the week, not so, because everyone's out partying or prospecting, hopefully. But, yeah, I hope that enlightens people to the hows and whys of why we keep going. We just didn't stick with penicillin, did we? And never innovate. Well, same thing applies. So, yeah, I'll tell you what, guys, try and get a 0.012 and show me if you can detect it. I'll be very surprised. Anyway, leave it there. Catch us.